Hello, everyone. The session will start soon. I'll just mention first that the session will be recorded in order to be made available on video on demand later. I am muted. Thank you very much for the reminder. Hello, everyone. I'm Mathieu Duchemin. I'm a consulting and support engineer with the ZK framework. Today, I'm going to give you an introduction to some powerful out-of-the-box ZK features. I hope you will find it interesting. You will probably see a thing or two that you already heard about, and hopefully we can go into a bit more detail into how it works, why it works, and what the best use cases for those features are. Okay, there will be some code example. There's going to be some running example. At the end of the session will be recorded and made available on video on demand. And the PowerPoint that I will be using to introduce the different feature is also going to be made available. So you will have access to the links and to the sample that I'll be presenting today if you want to check them out on your side at the end. Let's get started. So the first feature that we're going to discuss is render on demand. Render on demand, the general concept is that your application usually will have some data to display. It can be simple data like a username or some property of a specific object, but in many cases, you will have a lot of possible data existing in your backend and a limited amount of screen that you can display that data on. For example, if you want to display rows of data in a table component, such as a grid or a list box, the end user might have a total of 20 line of data available on screen, because that's how their screen size is, and they cannot display more than that at any given time. And on your backend, you might have much more than that. You might have 1,000 line of data, or 10,000, or 1,000,000 possible different line of data. It would be somewhat inefficient to display all those lines at the same time, considering that the end user will only be able to see about 20-ish at any given time, and spending the server resources and the client resources and the network resources to transfer all of that data to the client for it to just be in a non-displayed block is kind of pointless. So we're going to try and reduce the quantity of loaded data to be as close as possible to the available space on screen. Okay, so the first concept we have to get around is the concept of the page and the viewport. So not quite render on demand, but associated to render on demand is paging. That one is pretty simple. I'm assuming everyone has had the chance to open a book at some point in their life. You have a book which is the entirety of your data. You have a page open in front of you that is the currently visible data. And in the case, apologies, in the case of our component, we will want to only have rendered the current page of data. So this is a feature that is called paging in ZK. It comes standard with tabular components, so your tree, your list box, and your grids. And it works a little bit like this. Here I'm going to a sample code. You will have those sample code from the ZK books available through the links in the document later, if you're interested in running them on your side. Okay, so what do I have here? I have a tabular component with 5 rows of data. Just the first one's empty. I have a paging control. I have a total of 32 pages, and I will have the ability to go from one page to the next. When I go from one page to the next, I'm sending a request to the backend. I'm going to have to disable responsiveness. Okay, there we go. I'm going to be sending requests to the backend, and I'll be able to see that through the network tab in my developer tools. So, for example, just here on a fresh start, if I click the next button and I go to page number 2, you will see that I trigger a request response cycle. The request is on paging and it's sending the page number that I'm trying to display. And the response is simply the new content for the component. You can see here that grid is triggering data loading and it's loading data for the page. It's just throwing the 5 rows that exist in page number 2. If I do this again, I'll have the same result, but this time I'll be loading the page with the index number 2, and the response will be the content for that page. So in total, I have a lot of different rows that might exist at server side, but I will only be displaying 5 of them as at a given time. If you think about it in a more abstract way, the active page will be loaded. The component that represents the active page will be sent to the client and will be displayed. The previous page and everything before will not be displayed. The next page and everything after will not be displayed. So at once, you will only render one amount of data, which might be just a small percentage of your total available data. So this is not quite ROD, but it's related. However, the interesting feature that we're here to talk about today is render on demand. So render on demand is close, but with a crucial difference. With render on demand, you will have, from the end user point of view, the experience of scrolling through an entire list of data without stopping to load new pages every so often. This is an illusion for the end user. In reality, what happens is you have an active viewport, which is the currently displayed zone in the client. And you have a zone above the viewport, which is not displayed, a zone below the viewport, which is not displayed. So the logic is the same. If you only see 20 lines on screen, you don't need everything that is before it, and you don't need everything that is after it. ROD will let you control this in such a way that it is transparent for the end user. And it will look like this. Here I have a grid component, sorry, listbox component. When I scroll down this listbox component as a end user, there is content below and I can keep scrolling. There's a bit of a loading event from time to time, but depending on your server speed or network speed, it might be entirely transparent for the end user. And when I get to the bottom of the list as the end user, essentially I've never clicked on next page. I've never clicked on load more data. It's just, it gives the experience of having scrolled down an entire list. However, this is a bit of a lie in terms of what's actually happening. And the end user doesn't need to know that. What's happening here is in the listbox body, there is a table row, and that table row contains every currently rendered rows of the listbox. At the moment, I am at the top of the scroll area. So you can see that the first list item is the list item for my first cell here, which contain a blank character. However, if I go down and scroll and trigger a loading event, which the end user does not know about, At some point, when I go past the loading trigger right here, the content above a certain space is now unloaded, and the first row that is being displayed is no longer the actual first row of the component. Instead, I have here a top pad, which creates a fake 4,000 pixel tall buffer on top of my scroll bar, which still allow me to scroll up and down as if the same number of rows were physically present in the component. However, I will only be displaying the current amount of rows that is a bit above the viewport and a bit below the viewport. Okay. And of course, when I go back and scroll back up, those lines are recreated, and I will return to a state where I can actually show the initial line. And at this point, instead of having a top pad, I have a bottom pad under my content, which will create the additional space necessary to maintain the scroll bar position. Okay, so let's go back. How do we control this? When we want to use a render on demand effect on ZK component, especially on tabular component, the grid, list box, and tree, we are going to need a better way to render the data than simply creating list item one by one manually. We don't want to go to the ZOL file and then type list item number 1, list item number 2, blah, 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 blah. We want instead to use a model. The model is a out-of-the-box class available in ZK, which will act as a list or as a set or as a map, depending on the one you choose, and will automatically tie itself to the grid, the list box, or the tree component. When you use a model, by default in ZKEE, you will have the ZKEE ROD, render on demand. And if you have ZKCE instead, you will have live data, which is similar but slightly different. It's also a performance improvement because it will also load the node sequentially when the user draw. It works slightly differently, and I don't really want to spend the time to go into the detail for the differences. If you're very interested in that, we can discuss it further in the Q&A question at the end. Okay. So how does that work? When we add a model to a ZK grid, a ZK list box, or a ZK tree, we essentially tell that component, I want you to render a number of items, which is the same as the number of items that exists in my model. And I want to do it with two possible ways. The first way is to use a model and a template. In a ZOL file, I can define a template which is going to be instantiated for every single line of my model. And I can also do it in a Java way using a list item renderer or a grid row renderer, which are Java classes which receive the individual data object and output each row item. Both of them essentially do the same thing. They just do it in a slightly different way. The template have each variable which is the individual row of data in the model, and the renderer have the data object, which is the individual data object. They are the same object, just retrieved differently in those two cases. I'm going to go ahead on this. If you have, again, more question on templates and renderers, we can go back to it in Q&A. I just don't want to spend too much time on this because it's not the main focus of the discussion. Okay, so how do we use model classes? We have 4 default ZK implementation for linear data. Linear data is simply sequential data that you will display in a grid or a list box. You will have your list model array, list model set, and list model maps. I'm assuming that most of you are familiar with the list, array, set, and map interface in Java, and their different implementations such as array list, hash map, etc., etc. Essentially, those ZK classes, out of the box, are wrappers for a list, for an array, for a set, or for a map. However, they do more than simply wrap a collection. They bind themselves to their individual components. When you add a list model list as the model object for a grid or for a list box, the list box will actually listen to changes on the model itself. So if you do list model add or list model remove or list model set value for a specific node, the tabular component will automatically update itself. In the case of render on demand, we use this model object because those model objects have the ability to store the entire list of data at server side. And then when the user scrolls down into the relevant component, the list model will be able to provide the relevant row to the client. Okay, there is a hidden fifth list model. It's not exactly out of the box, but it's very interesting, so I want to discuss it quickly. It's the custom list model. Those classes are available in your application to be extended from. There is a abstract list model which comes out of the box in the ZK packages, and you can yourself extend abstract list model and implement your own list model. Why would you do this? Simply put, the 4 classes that exist out of the box are wrappers for a single internal list, a single internal set, a single internal map, or a single internal array. We can actually have a quick look at the code for this. Going to list model list, you will see that essentially we have here our internal list, and then we have additional code that happen on that list. For example, if we add an element using the add method, you can see that we're actually adding an element to the list, and then we're firing internally a list model event. And that list model event is then listened to by the grid, listened to by the list box, or whichever other component you're tying your list model to. You could implement your own abstract list model, which does something slightly different. For example, a classic use case to implement your own abstract list model is to have a list model that does not cache data in memory. If you have a database with 10 million items, you don't want to front load your 10 million items into a Java list in server side. That would be somewhat inefficient. So instead, when you do get element at, which is one of the method implemented from the abstract list model, you would want to do my DAO provider get elements number X to X plus 50 from the database. In this way, you would be able to just keep the internal cache entirely and have a implementation of list model that just does not have a memory footprint at server side. There's some small talk about this. Again, if you're interested in more detail, we can have a longer form chat later about all of those topics. Okay, let's go back to the presentation. All right. When we are talking about ROD, we also need to mention that there are 2 different kinds of ROD. We have client-side ROD and we have server-side ROD. If you remember, just a few minutes ago, I was showing you a sample case right here, wherein we have only a certain number of lines currently loaded inside of the list box. And when the list box is scrolled down, the lines that are above a certain threshold are removed, and the new content for the current viewport is loaded. This is called server ROD because we do not keep the data in memory at client side. The server is being called with a ZKAU request, again, data loading and a response containing the data rows for the content every time the content has to be displayed. However, there is more to this. The server ROD is available for the list box within tree, as I mentioned. you have some sample available, and it also works in a slightly different way for shadow elements. And we're going to be talking about shadow elements later in this presentation. So I'll keep that for the next chapters. Okay, and then we have client ROD. Client ROD is slightly different. With client ROD, we will load the data in the client memory, but we're not going to draw all of the client HTML representing that data unless the user actively goes and display that data. So the main easiest way to show how this works is to use Tabbox. So let's go to a sample case and let's show a Tabbox. I've skipped a bit on my sample. We have here a sample of the custom list model and how to implement it. Already mentioned this, that is fine. Okay, here's our Tabbox. It's a ZK Tabbox. Out of the box, it doesn't have any specific attribute. It doesn't have any additional configuration. If you have your library loaded with your client ROD, you will have this behavior out of the box. And what it does is when you load your Tabbox in the view, you will see here that the first tab panel is rendered because it is currently in view, but the second tab panel is just an empty div with display none. It doesn't have any content right here. When I go ahead and click on tab number 2, I will be displaying tab panel number 2. At this point, the content of the node tab panel number 2 will be filled out. In this case, it's just text, but of course, in a more complicated UI, you might have a lot more information inside of that tab panel. Okay, and in this case also, that's an important thing to mention. There is no network connection because the information is preloaded when the component is created. However, it's just not rendered until the relevant panel is being drawn. Okay. All right. Let's keep going. We're almost there with ROD. We're going to be talking about a few more things, which are specifically how to enable and disable ROD. So first off, client ROD have a single property for turning off or turning on all implementations of client ROD. And you will find this property in our ZK documentation in the performance tips. The property that control client ROD very simply is the client ROD true, client ROD false property. It's available in two formats. You can set it in your ZK XML as a library property to either enable or disable it globally. But you might want to have more granular control. You might want to be able to disable ROD on a page or on a specific component and its descendant. When you have that requirement, you can simply add a custom attribute inside of a specific item, in specific component. And for that component and its descendant, the status of client ROD is going to be the one that you define. And if you override that status at a lower point, it will override it for the descendant of that specific target. So in this case, the descendant of the window will have ROD set to false. However, the descendant of this specific div, even though it's in the window with ROD set to false, will have ROD set to true, but the other children of window will not. All right. Is ROD conf ignore for listbox if paging mode is used or paging mode is set? That's correct. There is a bit more requirement for ROD on listbox and grid, and that's a good point. Thank you for bringing it up. Okay. Specifically, in order to have render on demand on the listbox or on the grid, you need to have a fixed size on your listbox, because the listbox itself has to be scrollable in order for the content to scroll up, scroll down, and have the ability to render more node or render fewer nodes. You also cannot have render on demand with paging, which is to be fair, already it makes sense because paging is similar to render on demand in concept. It already limits the number of rows that will be loaded at a given time inside of the component. And if you use Paginal, it's also a similar concept. Even though you're not directly using paging mode, you're using a display by page, and therefore you're already limiting the number of rows that you're going to be displaying at a given time. Okay, let's keep going with how to enable and disable server ROD. So actually, it's going to be tying down to that small aside, which is turning on and off render on demand for grid, listbox, and tree. There is a prerequisite, as we mentioned. You need to have a model object like a list model. You also need to have the grid or the list box or the tree having a fixed height, either with the height attribute or the vflex attribute. And then you can either enable or disable grid ROD, list box ROD, and tree ROD globally with library properties, or for a given grid or a given set of grid granularly with custom attribute. Logic is the same. Note important information that there is a ROD toggle for grid, specifically for grid. There is a ROD toggle specifically for listbox, and tree doesn't have a specific toggle. Instead, if you set the ROD size to -1, so a negative value, the ROD will be disabled by default. All right, I think that's basically it on the ROD. Let's talk about a different feature, still mostly related to listbox and grids. This one is perhaps not as powerful or complicated as render on demand, but it's new and I like it, so I'm taking the chance to talk about it today. So we have in ZK 960 a new S class that you can put on grid, listbox, and tree, which is the sticky header S class. The sticky header is very simple. Here I have a listbox component which has data, and if I scroll down, let's go to a default page. If I scroll down my tabular data out of view of the screen, you can see that at some point when I scroll past the header, I am no longer able to see that header. And that's going to be resolved if you want to always have the header in view by adding the sticky header S class on your grid, listbox, or tree. In which case, when you scroll down past the top of the grid, the header will stay at the top of the screen. And if you happen to go further down where the listbox is no longer on screen at all, it will actually go away on the top of the screen. And then when you go back, there it comes again. It's very easy to implement. There is a sample in GitHub. You can see if you're interested, as well as documentation in the ZK documentation. You simply have to ask the zsticky header to your grid, to your listbox, or to your tree. And that's it. All right, let me just grab a little bit of water before we move to shadow elements. All right, let's keep going. Shadow elements. Shadow elements are powerful tools to structure a Zool page. They can be used in MVC, in MVVM. They were initially designed for MVVM, but they have a specific attribute that lets them be useful for MVC as well. Let's talk about what they are, what they do, and why they can improve dramatically the performance of a page. Let's say you have a single page which have a lot of potential different content. Let's say you have, for example, 3 different panels. They all have different tree, grids, list boxes, form, pop-up window, a lot of stuff that could exist in the page. And you want to have the page content switch between those different states, depending on your application states and user actions. For example, you might have a form in edit mode, a form in read mode, in print mode, tabular, all form list, etc. And you want all of those to coexist in the same page. The non-efficient way to do this would be to have all of those components exist at the same time in the page, set them visible or non-visible, depending on what the user would do. The issue with that is a component that is not visible still exists. It still exists at server side. It has a footprint on the server memory, on the server processing. It will receive event, it will send event. It will have side effect if the children of that component are added, removed. It does stuff essentially. And at client side, those components also have an existence. They take up space in your network transaction. They take up space in the page processing power at client side. Not everyone has the best laptop ever, so sometimes the end user laptop can be overwhelmed if there is a million of components on screen at a given time. So how do we fix that? Shadow element essentially divide a page into logical segments. And those logical segments are going to be loaded and unloaded depending on the conditions you set. Why is this powerful? Because you don't need to keep the component in memory at server side. You don't need to keep the component in memory at client side. You only need to change the conditions, and the page will automatically create and delete components for you. How does that work? First, to use the shadow elements, you're going to need the ZUTI package, which is available in the ZKEE package. It's going to be available through Maven and Gradle if you're using source control, or it's available in the downloaded package if you're using the ZK downloads directly. There are 4 major shadow elements that we want to talk about. The first one is apply. Apply is the simplest shadow element. Essentially, you're telling your application, I want to insert content here, and that content will be a given template or a given Zool file that I want to instantiate, and I will be able to pass variable to that apply. Let's take a look at a code sample. Here, this is the most basic use case. That apply has a template attribute, and that template can be modified by either a load binding in MVVM or by accessing the component in MVC through Composer. When the value of VM edit is edit, I will load the template called edit. When the value of VM edit is normal, I will load the template called normal. Those templates are pretty similar. The only difference is in one case, I have a bunch of labels. In the other case, I have a bunch of text boxes and inboxes. From the end user point of view, it's entirely transparent. Here I see the view template. Here I see the edit template. And since those templates are tied to the same view model values, I can actually make changes to those elements in the edit template, go back to the view template, and the model value will simply be applied back to them. Oh, sorry about that. About this template here, we're not passing variable, but apply also support variable. So I could say here, my var equal something, equal either a direct value or a load binding or an init binding or anything that I would want to pass to the apply. And when I instantiate those templates, I can refer to those variables and retrieve their value. Now, what happened here? You've seen that when I click the edit button, I switch between the edit template and the show template. You might be thinking that this label, for example, is the same as this label after I click twice. That's not the case. The shadow elements work on a principle of recreating their content every time their conditions or their variable are changed. This is very useful because it lets you define variable-driven part of UIs. And when those variables are changed, you can recreate entirely those parts of UIs and then simply redraw them at client side. This is very good to avoid synchronization issues. This is very powerful if you want to force a given set of display object dependent on the same variable to be redrawn. However, it can be a little of a trap as well. If you're notifying too much and you're redrawing everything all the time, you might be recreating components that have not been modified. So when you do your bind utils post notify change or your add notify, keep in mind that using star is the easiest solution, but not always the most performance efficient one. Okay, so that's it for apply. Let's go to the next one. Next one is shadow element if. Shadow element if is very similar to apply. You will have a template that you give to the shadow element. However, the shadow element if has an extra thing. It has a test attribute in which you can give a condition. Essentially, it's an element in Zool that will act like an if-then statement in Java. If the condition is true, create the content. If the condition is false, do not create the content. If the condition was false and become true, content become created. If the condition was true and become false, content is removed from the component tree. It works in exactly the same way. If we look here, oh, I thought I had an if statement ready. Sample in GitHub, please. There we go. It works like this. You have your test, and if your test resolve to true, this will be created. If your test resolve to false, this will be removed. Very simple. All right. Those were the easy one. So now we have two shadow elements that are slightly more complicated, but still very useful. First, we have choose. Choose acts like Java switch case. You will be able to define a condition and then a number of different possible templates or possible result depending on that condition. And you can have more than two with this system. Exactly the same as what you would have with a switch case in Java. To do so, you have the choose tag, which have the test, and then you have a number of when tag, which are your different option. And then in the end, if you want a default case that will be added if none of your when case are being triggered, you can have an otherwise statement, which will be your default. This is exactly like switch case, so I don't think we need to spend too much time on this one. Then lastly, we have for each. For each is very powerful, and it's one of my favorite shadow element with apply because it's at the same time very easy to use and it can be used for great result. So if you remember a bit earlier when I was talking about render on demand and displaying data dynamically for the end user, I mentioned that there is something related to, but not quite render on demand with shadow elements. This is it. This is the for each statement. So what does the for each do? It has two modes. In the first mode, you're able to bind a iteration on a simply a variable. So for I equals 0 to I equal 100, for example, which is useful, but not the main course of that component. The best one is collection binding. You can give a collection to a for each shadow element, and the for each shadow element will instantiate its template for each object in that collection. You can give it a default Java list or a set or this type of object, but it's much more powerful with a ZK list model. If you give it a list model list, I mentioned before that the list model list will have its own internal event manager, which will send on node added, on item removed, on item update, to the different thing that it is bound to. It will bind itself to the for each, and it will be able to create, remove element from the list of children of the for each automatically when you make changes to your list model list. It will look something like this. Let's go back to the code sample. There we go. You will give in the items attribute of your for each, you will give a collection, in this case, a list model list. And then the template located inside of your for each will be created for each item of that collection, with the each variable by default being the data object for that entry in the list. So for each object in my item, I will create a link component with a label which is the X value of item, and with an on-click command which which triggered the command nav2 with the value level being level and the value key being self.label. This, if in my navigation view model here, if I make a change to one of the items in this collection and trigger a notify change on that specific item, not on the entire collection, I will not recreate the entire list of items. Instead, I will only recreate one of those items, the one that correspond to the item I have notified. Okay, let's keep going. Again, for all of those, I know I'm going fast. If you have any additional question, we'll have a Q&A at the end, and we can go into more details. Let's go forward and talk about another topic that is coming up from time to time, responsiveness in ZK. So let's first have a general talk about what responsiveness is. I'm sure everyone here is a professional and has had at least 1 or 2 meetings talking about responsiveness in web design, but we're going to go over the basics so that everyone is on the same page. Responsiveness, the core of the issue is not everyone will browse your application with the same device. Some people will have a laptop with a normal size screen. Some people will have a power workstation with an enormous screen that take up all their desk. Some people will browse your website on a mobile phone. Some people will use it on a tablet, like an iPad or other tablet device that they might have. And essentially, you will have very different experiences looking at the same website, depending on which device you are. Responsiveness will attempt to give the best possible experience to each user, even though they are browsing the same page, by tailoring the page to the device that they're using to browse the page. It comes into mainly 2 different flavors. The first big flavor is actual responsiveness. A responsive page with a responsive layout or a responsive design will actually show different components or different layouts depending on the page width or on the different media query that resolve on the page. A media query is simply a set of information from the browser, such as the device resolution, whether or not it's a touch device, etc., etc. You can see in this sample, in a desktop mode, for example, I would have 2 rows with a specific order of components. But if I switch to a tight layout for mobile phone, those rows will be removed, and instead I would have all of my items in the same container displayed sequentially and vertically. That would be responsive design. There is something else which is close to responsiveness, but is not quite responsiveness. It's fluid design, where you keep the same elements, you keep the same element layout, you keep the same element order in the page, but you simply change how they size in regard to each other, depending on the size of the page. It's called fluid design, and usually it can be achieved with fluid design systems such as Bootstrap Grid, which are pretty useful to give those different sizes as different screen size for your components. I'm not going to go into too much detail on responsiveness because we actually have a bunch of resources in our documentation and in our blogs. I'll link to those at the end if you're interested in looking further into this. However, we have, and that's the interesting part, responsive design tools available in ZK, which help in making your ZK page more responsive and easier to handle for the end user, regardless of the device that they're using. What are those tools? So the simplest tool that you will have access to in every single ZK page is the client info event. The client info event, let's go to here. The client info event, you will have more information in the documentation as linked in the PDF, the PowerPoint once released. Essentially, it's an event you can listen to on your ZK page, and that event contains information about the client. It contains very useful information such as the width and height of the desktop. It contains media queries which you may want to match. It contains the screen orientation. Is the user using portrait mode or landscape mode if they are on a mobile device? It contains the user zone ID if you want to know about the time zone they're in, etc. All of those information are very useful in order to build a page which going to provide different controls for different scenarios. For example, you can listen to the client info event, find out that the page is larger than 800 pixel, which is one generally accepted delimitation mark for switching from laptop to mobile UI. And if your page is larger than 800 pixel, you will want your menu bar classic. If it's under 800 pixel, you will want to change that menu bar into a hamburger menu and tap to scroll down. Those things are quite useful, but there is a second tool that I will want to talk about. It's the match media annotation. The match media annotation is specifically for ZK MVVM. So if you're using a view model, you will be able to declare match media. If you're familiar with media queries in CSS at client side, you will find that this is exactly the same syntax. And what happened essentially is the match media method is going to be triggered whenever the match media become true. So for example, if I load the page and the max width of the page is 500 pixel, this match media annotation will trigger, and this method will trigger, at which point I will be able to change the template that I'm using. I'll be able to do something based on my desktop width. I'll be able to change my window from a floating window to a full screen window to better serve a mobile device. And if at some point during the page lifecycle, if the user is browsing the page and, for example, turn their device to the side and suddenly the screen size is more than 500 pixel, I will trip that match media query, and this method is going to be invoked. So it's not only at page load, it's whenever the desktop information changes. Okay, let's continue. There is one more level of responsiveness that comes out of the box with ZK, and those are the responsive ZK components. I'll be somewhat short on that front. Again, we're almost at the end of the hour, and I don't want to keep you tied down too long. Let's go. Those touch device enhancement are available in ZK EE and are part of the ZK Max package. When you are browsing, for example, a time box. I'm currently on a desktop browser, so I will be able to use my mouse, my keyboard in order to type in interact with the components. However, this would be harder to use if I were on a tablet or on a mobile phone, because I would not be able to simply select and type. I would need to go in the input and then browse to the position. That's annoying. I don't want to do this with a mobile phone. So how to do this better? If I am loading this page as a mobile user, I'm currently using mobile emulation in order to show you this. You'll see that instead of a up-down arrow, I have a slightly different view on my component at the moment. And when I actually focus my my time box here, I have a mobile specific pop-up showing up at the bottom of my screen, which contain touch scrollable controls, which are easier to use with a touch device, and larger buttons, which are easier to access. This makes interacting with my time box much easier than simply trying to access it as if I was using a mouse and keyboard while I don't have access to a mouse and keyboard. There is a lot of those different improvements. I'm going to go quickly. So this is the time box enhancement. There is a scroll enhancement for the paging component, scroll by touch enhancement for the list box, extra. There is a whole list of different tablet enhancement that exist. Those are available in the documentation. If you're interested, you can go to the page. It again will be available in the PowerPoint presentation. And those essentially do not require any action from the developers. If you are using ZK Max, you will have this behavior enabled as soon as the client with touch activity is detected. You can disable those touch device enhancement if you want to remove them from the mobile user experience. That's a choice depending on your application. In general, they're useful, but there are some edge cases where you want the end user to have the keyboard input instead. So it really depends on the use case. Okay. There is a bit of further reading if you're interested in responsiveness. As I mentioned before, we already have done a few articles and talk about this. We have a admin template demo, which I quite like in our website. This admin template demo is a good example of a responsive page. So you can see that at max screen size, I will have all my elements in a specific layout. If I go to my developer tools and then, sorry, I'll have to disable this, and then resize my page down, I will trigger events in my network where I trigger my match media query. You can see here the match media that are listened to at server side. And at the same time, at client side, I have fluid layouts which will rearrange the different component with each other. Those are a pretty interesting use case if you're looking into the different option to add responsiveness to an existing ZK application. I'll recommend this one as a case study if you want some nice use of the match media query, the client info event, and the different responsiveness of layout that can be done with out-of-the-box ZK. Okay, we also have a general responsive design information page where you're going to find more data about the different things I was talking about today. And at the very end, you will have a very long form series of articles. We have responsive design in ZK part 1, 2, 3, and an article on the creation of the admin template. Those are a bit of a read, but they go into a lot of details on responsiveness and the best practice of responsiveness in ZK. All right, we are almost at 1 hour of time, and I have for once stayed just under the time of my presentation. All of the samples sample code I've shown you today is available on GitHub. The PowerPoint and the video of the presentation will be made available later if you want to find the links or play with the sample yourself. If you have any question or any feedback on this presentation, we would be very happy to hear from you at info@zcos.org. And now let's go into question and answers. I know I've been talking a lot and talking very fast. If you'd like to go into more detail into all of the topics we've been discussing today, now is the time. And if you are happy with what you've heard so far, I'll say have a good day and thank you for joining. All right. Is there any question we would like to discuss during the Q&A session? I'm going to keep the call open until 4 more minutes. So if you have a question, try to either let me know before that you're going to post a longer text or just put the question in directly. And otherwise, if you're not interested for a question and answer, as I said, feel free to end the session for now and have a good time. All right, thank you everyone. Then I think there doesn't seem to be any question at the moment. So I hope you enjoyed this presentation. I hope it was informative and helpful. And in any case, I was very happy to have you with me for this talk. Have a good day and see you later on a different training. Thank you everyone, goodbye. As I mentioned, I'll still keep the call open a little just in case there's more question. Just let me know if you have any. Thank you, everyone. Goodbye. Right, I'll be closing the call in 1 minute. Just a reminder, if you have any question, you only have 1 minute to post it. All right, then looks like there is no question at the moment. Thank you for everyone who is still there. Hope you had a good time and I'll be closing the call. Thank you for joining today. Goodbye.